There you
Okay.
go. I won't move.
Okay, we're doing independent and dependent today. Get out your highlighters. And first of all, let's highlight the part that talks about independent. Everybody say independent. All right, so in all of these, either two things are happening or two or more things are happening. And so our decision is does one affect the other, okay? So if they don't affect each other, that's independent. Everybody say independent. Whereas if one has an effect on the next one, that would be dependent. So let's talk independent first. The best way to do this is just to read through some examples. And then after I get done going through all the independent, dependent explanation, we're going to go back and calculate the probability so you can see that too. So the first one, number one, it says, what is the probability of rolling a 5 and then a 3 on a die or dice? You guys know what a die is? Dice?
Yeah.
But die means just one. You guys know how good of a drawer I am. Part of the issue here is some people don't really have experience with dice or cards or whatever the case may be. So you guys know what a dice looks like? So if it doesn't say otherwise, it's a 6-sided dice numbered 1 to 6. Very good? I just marked you opposite, Michelle, so remind me to fix that because I am to look up all the way. Okay, if I take a die and I roll it and I look at it, right? Did I roll a 5 or not? And then I pick it up, what do you always do? Shake it, roll again. Does one affect the other? It does not. So that is why this is independent, right? One does not have an effect on the other. We will come back and talk about how to find that probability later. Okay, I do not have 4 children, but let's say I did. What's the probability that all 4 children will be boys? So, and so in the good old days, women got pregnant naturally, right? You get pregnant, you have a baby. You get pregnant again, you have another baby. Does this pregnancy have any, did that pregnancy have any effect on this one?
No.
No, it doesn't matter, does it? Because every time you get pregnant, it's the same options, right? Same chance, it's either a boy or a girl. Everybody agree? And I say naturally because nowadays with technology, like they can actually, when they artificially inseminate somebody, they can take the sperm and the egg and they can pick out the ones that were girls versus boys and put those in, you know what I mean? Isn't that crazy? So I have to say natural, okay, natural. So everybody agree that each pregnancy is independent of the other one, right? So independent also. All right, next. So now it's talking about cards. How many of you have played cards before on regular standard deck? Okay, but there are students that have never ever played with a deck of cards, so they don't know. But in a deck, there are, and I'll write this up here later, there are hearts, diamonds, clubs, spades. There's ace, king, queen, ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 of each of those. So there's 52 cards.
And a joker.
This says, what is the probability of drawing an ace? You guys seen an ace before?
Yeah.
Big, pretty A. And then it says replacing it in the deck, like shuffling it back up, and then picking another ace. So does the first ace have an effect on the second ace? Well, there's one key word. What is it? Replacing. Because you replace it and you're starting over, it is independent, which would be totally different than if I looked at the card and I set it out and then I picked again, right? Then it would have an effect. All right, everybody understand independent? Pretty simple. Okay, everyone highlight dependent. So dependent, it changes as you go because it does have an effect. So I only have 2 questions on this part. The first one says, what is the probability that you draw a king from a deck? You keep it in your hand, right? This is kind of how Vegas works. And then the next card you get is a queen.
That's a good hint.
Is that independent or dependent? That's dependent. What's the key word that makes it dependent? Keeping the card. Because as soon as you keep the card, it changes the cards that are left. Does that make sense? Like there's not the same amount of cards left. So it changes it, it's dependent. And then my favorite question is question 5. So I don't know about your house, but my house growing up, there were 5 of us. My mom did all our laundry because she was the greatest mom ever. We never had to do laundry, right? So there's a lot of clothes, they're all mixed together, and then she's putting them away, and what always happens is there's a bunch of socks left over that don't have a match. Does that sound right?
Yep.
Okay, if you've ever done laundry. So there's all these socks and that they don't match. So there was this huge drawer in her room where she would just put all those socks. So over the years, that sock drawer became crazy with a lot of socks in it. So we called it the sock drawer. And when you were out of socks and she hadn't done laundry, you could go to the sock drawer and dig through it and try to find 2 that matched. Everybody got it? So nowadays, I notice kids don't even wear the necessarily matching socks. They don't care, right? They just pick 2 socks out, they wear those. My kids are like that, or at least Jess is, right? They cannot match at all. But that's this question. So there's this big drawer of just hodgepodge socks, right? And it says, what's the probability that you get 2 black socks? That's what the question's saying, okay? So if you were actually looking in this drawer, okay, and you reach in and you pick out a sock, and it's black. We get to assume it's black. Everybody got it? We're gonna set it down, because you wouldn't get it and then put it back, right? You're gonna wear it. So you get it and you set it out, and then you reach in and you get another one. So is this independent or dependent? It's dependent. It's dependent. Everybody agree? Because it changed. Here we go. Okay, so that's the idea, is knowing whether things are independent or dependent. Now let's back up. Oh, by the way, I fixed this as a mom because I'm a genius. My sons all have the same socks. They're all black. So it doesn't matter, right? They all match. It's awesome. I'm a genius. Stick with me for more parenting advice later. All right, let's back up. Let's back up to number 1, and let's see how will we calculate this probability, okay? So this goes back to yesterday. A couple things. It says, on number 1, what is the probability of rolling a 5? And then a key word here is the word and. Everybody say and. In probability, and means they both have to happen. So in and questions, we multiply. Everybody say multiply. Okay. If both things have to happen, we're going to multiply. All right, here we go. Probability of rolling a 5. So I'm going to do this. I'm going to put P of 5 times, because it's multiplying, and then P of 3. Is that fair? Probability of getting a 5 times probability of getting a 3. This is the rolling the dice question, right? So we're going to set up a fraction. So what's the probability that you roll a 5 on a dice? 1 out of 6. There's 6 choices, right? Because there's 6-sided die. We always assume that unless they say otherwise. And there's only 1 5 on it. Very good? Okay, then we pick it up, roll it again. What's the probability of getting a 3? It's still 1 out of 6, because there's still only 1 3, right, out of 6. So that would be 1 out of 36. And then I already said, my expectation is that we give decimals, right? Because that keeps us from having to worry about simplifying fractions or whatever. So this should be 0.028. And I always go, there's a 0 there. So check it and make sure you got that right. I need a drink of water, please.
Stop messing with Brian.
All right, everybody good? Thumbs up? And you're okay? It's not so bad? Okay, let's go to the children question. What is the probability that you get 4 boys? boys.
That'd be amazing.
Jeez.
That'd be great.
That's a lot of smelly feet. Probability of a boy, 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 right? You know I'm not wrong. All right, so we're gonna do, right, 4 boys, probability. So I set up 4 fractions, piggybacking on what we did yesterday. Are we ready? What's the probability of getting a boy first time? 1 out of 2. There's 4 choices when a woman's pregnant? 1/2, right? Boy, girl. Boy, girl. Boy, girl. Okay, next pregnancy. 1/2. Next pregnancy.
1/2.
Next pregnancy. 1/2, right? So that is 1 out of 16. And when you do 1 divided by 16, 0.063. Is that right? So is that a high probability of getting all boys? No, it's not. It's, no?
What?
If you move the decimal, it's 6%, right? 'Cause you gotta draw the butt. It's okay. All right, 3, probability of getting an ace and then another ace. So probability of ace and ace. Okay, so here's where I need to help out the folks that don't know cards. So I'm gonna help you guys out here. I'm gonna put it over here. So in a deck of cards, there's 52 cards. Some of you already know all this, that's fine. In that deck of 52 cards, there's 4 suits. There's the red hearts, the red diamonds. I'm really good at drawing. There's the clubs and the spades, something like that. So there's 4 suits. Shh. Of those, there are 13 cards for each of those. And that's broken down. Ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. Does that make sense? So that's the kind of cards that are in a deck, so that you know. So there's your information on cards. I grew up playing cards. Like, I don't remember a time in my life where I didn't play cards. So, like, it's something that I just assume people would know. Okay, number 4. What is the probability of drawing a king from a deck, keeping it, that's super important, and then getting a queen? So probability of
We didn't do that.
Oh, I never did the ace one. Thank you. Sorry. Thank you. Back up. All right, let's do the ace one. See, that's why I need you guys. All right, probability of getting an ace. This is where you replace it, right? So how many aces are there?
4.
4 out of 52. Good job. Look at it. You assume you got an ace. Great. Put it back. Shuffle it. Probability of getting another ace. 4 out of 52 again. So you would multiply those together, divide. I'm going to go straight to the decimal. Is that okay? So 0.0059. Somebody back me up? Is that right? Is that very likely? No. And if you play cards, you know, like getting aces or getting 4 of anything. That's why that's a really good hand in poker.
Yep.
All right, okay. Everybody understands independent. Okay, let's go to dependent. This is what it really looks like though when you're actually playing cards. Probability of a king, probability of a queen. So in poker that makes sense because you're trying to get a straight. And when it's the king and queen and those, it's a royal
Flush.
straight. If they're all in the same suit, it's a right. Whatever. Okay, so we're multiplying because we need both, right? It's and. All right, what's the probability of getting a king? 4 out of 52. So we have it, we keep it in our hand, because that's what happens when they deal you cards, like it's yours, right? So now, what happens? The 52 is not 52, it's 51, right? Because a card came out. It changes as you go. How many queens are there? 4. There's 4. Now, if it had said king again, it would be 3 out of 4, because you get to assume you got what you wanted. Okay, so 4 times 4 divided by whatever 52 times 51 is, I have no idea. I just know the decimal's 0.0015. So double check. Because as always, calculators are weapons of math destruction. We have to make sure we know how to use them, right? Okay, I want you guys, with your people around you, figure out the sock question without me. Ready, set, go.
Shoot.
Yeah.
It's wrong. The decimal's different. The decimal's wrong.
Is it different?
Yeah.
First period. What is it?
It's like 0060.
That's tough.
006?
0. Yeah.
Okay, let's just put 6 there. Thank you. I should change it on my paper. Oh, I put the answer to the other one, that's right. Or no. Okay, what do you think? So we want probability of black and probability of, wait, what's that? You're supposed to be
Did
doing
you
this
get
one.
8 over 20 times 7?
8 over 20.
18.
We'll assume you're colorblind also. So you can't see the socks, you can't see the socks. Alright, you guys think you know? Think you got it set up right?
Hang on.
Yeah? Alex, what's the
Oh.
probability that I get a black sock on that first draw?
You don't get to cheat days.
Wait.
There's only one black sock?
Oh, wait.
8 out of 20, good job. Okay, so we get to assume we got a black sock. We're gonna put it on our foot. We're not putting it back in the drawer, that's ridiculous. So now, over here, Esty, what's probably the next one's black?
7 over 19.
7 over 19, does that make sense? Because the black sock came out, that changes the denominator and the numerator, right? All right, now go ahead and multiply that out. So 56 divided by whatever that number is. 0.147. Okay, now I changed this assignment, and so on the back side is your homework, but you're missing some of the information. So you can take a picture of mine, or you can write this down. Because I copied it without looking at it carefully, because I shortened it. I shortened the assignment by half of what they used to get. But then when I was looking at it yesterday, I was like, none of these questions actually have you do the probability. It just asks you, is it independent or dependent? And I'm like, well, that's not good enough. So you do have to calculate the probabilities. Everybody got it? Not just say independent or dependent, but because of that, you're missing some information. So I'm gonna go through and discuss that with you. You are gonna cross out number 2 and number 11. You're not gonna do those two. Okay? Not because they're hard, but because number 11 is hard to see and number 2 is dumb. I didn't cover today. So on all of the rest, you're gonna decide independent, dependent, and then you're actually gonna do the probabilities. But, like number 3, it talks about a box of granola bars. You're gonna pick out a granola bar and eat it, because that's what you would do. And then you're gonna go in and pick another one. They want the probability that you choose a coconut almond and then a cranberry almond. But in order to answer that, you have to know there are 20 in the box, starting out, 20 granola bars, 4 of each flavor. Everybody got it?
Yes.
20 in the box, 4 of each flavor. Did you write it down? This is in Google Classroom, by the way, so you can see it, I think. I don't remember, maybe it's not. I don't know. Number 4, you don't need any information because they're talking about a dice and a coin, which everybody should understand. Number 5 is talking about MP3 players. Does anybody even use those anymore?
No.
That's how old this question came from. It talks about the probability of choosing a hip hop song and then a rock song. So what you need to know is on the MP3 player, there's 50 of each type. There's 50 hip hop, there's 50 rock and roll, for a total of 100 completely on it. That's all they got. Stupid, there's no country. Number 6 is talking about books on a shelf. There's 22 novels of various genres. It wants to know the probability of getting a mystery and then getting a science fiction. It does get put back on the shelf, okay? So what you need to know is that there are 22 novels. There are 2 of each genre, because there's a lot of genres out there for books, aren't there? You could have fiction, nonfiction. You could have romance fiction. You could have mystery fiction. You could have crime fiction. You could have little kids fiction, right? So there's 2 of each genre for number 6. Number 7 is talking about colors. You can't tell. So there's what it looks like. It's red, green in the top corner, yellow, red, and blue. You can just color them in or you can write letters on them so you know. Very good? All right, you get the rest of the period due tomorrow.